Hey guys, welcome back. Mr. Marone here with our third and final video in this trigonometry series. What we're going to look at today are a couple more in-depth types of trigonometric problems that you might see. The first one being a combination problem here. So in this case, we've got a flagpole on a building, and we have some information that tells us the angle of elevation both to the top of the building and the top of the flagpole. What we don't know is what's in between. And unfortunately, we can't use that triangle in between because it's not a right triangle when we're dealing with trigonometric ratios. So what we have to do is solve the two triangles and then find the difference in height, because the outer triangle is going to tell us the height to the top of the flagpole and the inner triangle to the height of the building. We need the in-between. So the first thing we're going to do is we're going to solve using tangent of 30. So we're going to solve that smaller triangle and find the height of the building. So tangent of 30, if we look straight across, the building and the flagpole are our opposite sides, and the street itself is our adjacent side. We don't know anything about our hypotenuse here. So I'm going to have my tangent side. This is going to be my x in both cases, and in this case I've got 300 as my denominator. Now if I multiply both sides by 300, I get x equals 300 tan of 30, which is approximately 173.21 feet. Now I'm going to do the same process over again, only now I'm going to use the tangent of 32 degrees to find the height of the building and the flagpole. It'll still be x over 300, and the solving is the same way. We're going to look for, we're going to make this one y instead, and it's going to be y equals 300 tangent of 32 degrees, which in this case is approximately 187.46 feet. So to find the flagpole, we just take our 187.46 and we're going to subtract the height of the building, 173.21. And after all is said and done, we have approximately 14.25 feet. And it did tell us in the direction to find it to the nearest foot. So the flagpole is approximately 14 feet tall. Okay? So we've just had to kind of combine processes there. So I've got a second one for you guys to try. It is a sailboat looking up at a lighthouse up on a cliff, and they want the height of the lighthouse. So what I'm going to do is I'm going to let you guys try this. You can pause the video and give it a try. When we resume, you'll have your answers worked out and you'll be able to see what I did in order to solve that. Okay, welcome back. So as you can see here, the process was almost identical, only here we had different angle measures. We had 18 degrees and 21 degrees. And when I solved out, I did make a little bit of a equation for us here. I made the lighthouse z, I made the entire length, including the cliff y, and I made just the cliff x, just to indicate that to find the lighthouse, we have to take our whole length and subtract the length of the cliff. And we ended up with an 18-foot lighthouse here. So that would be all we'd have to do for a problem where they gave us multiple triangles and they wanted us to find a piece of information other than in our right triangle. The next problem we're going to look at are when we've got two different figures and we really have two things we need to find. So here we've got two people that are standing on either side of a tree, and their total distance is 40 feet apart. And we want to know how tall the tree is. I'm going to make my tree H. And we don't know how far this woman, in this case Sally, is from the tree, but we'll just say that it's x. And looking at it, I've got h as my opposite side and x as my adjacent. So we can set up her equation as tangent of 42 degrees equals h over x. And we're going to leave that there for right now. Now, if we consider Jonathan on the other side, we don't know how far he is from the tree, but we know it's going to be the total of 40 feet minus the distance Sally is from the tree. So we can say that he is 40 minus x away. So his equation would be tangent of the 36 degrees based on his angle of elevation, and his equation will have the height on the top for opposite and 40 minus x on the bottom. Now, if you notice, if we multiply the denominator in both of these across, we end up with h being on each side. So I end up with x times tangent of 42 equals h, and I end up with, parenthesis, the quantity 40 minus x times tangent of 36 equals h. We can then substitute those in and set them equal to each other. And what I'm going to do is distribute this tangent of 36 to each of my two terms here and here. So I've got x times the tangent of 42. That's going to equal 40 times the tangent of 36 minus x times the tangent of 36. Okay. At this point, what I'm going to do is find out the actual values of each of my tangents here. So going to my chart that you guys have, we know that the tangent of 42 is going to be 0.900 times x. That's the same thing as x times the tangent of 42. We're going to set that equal to our value here. Tangent of 36 is going to be 0.727. So when I multiply the 0.727 times 40, I end up with 29.06. And then I'm going to have x times that 0.727 here. Okay? What I'm going to do now is I'm going to add x times 0.727 on both sides. And then I'm just going to bring it up here to work with. So I end up with a total of 1.627x on the left-hand side, and on the right I have my 29.06. I can then divide both sides by 1.627, and I get that x equals approximately 17.86. Okay? Now, we've got x. We have to go back to our original equation and find the height. So I'm going to use the easier equation, which was Sally's tangent of 42 equals my height h over this new x, 17.86. So I end up with h equals 17.86 times the tangent of 42, which is approximately 16.08 feet. And they want us to round to the nearest foot, so the tree is approximately 16 feet tall. So we had to use a little bit of algebra there and get a little creative, but it is possible for us to solve a problem like this. So you've got one more I want you to look at. Once again, we're going to use the same process here. We've got Betty and Kathy, and they're in Paris. So I want you guys to see if you can solve this. I'm going to pause the video and put in all the work, and then I'll let you guys see the answer as well. Okay, welcome back. So as you can see here, and I'll let you guys pause the video. I would encourage you to pause it if you're curious on how I got these steps. Look at this and see if you can follow along. We just did the same algebra and found that the x, the distance from Betty over to the cathedral, was 182.24 feet. And I used that to then solve for the height, which was approximately 74 feet to the top of the spire, to the nearest foot. So I encourage you to try these problems on your own and see how you do.